some of them anyway.
So we are at the 5 minutes past. I might just kind of get the ball rolling. I think we're hitting a sort of asymptote with the incoming participants anyway.
Sure.
So let me just begin by introducing myself. My name is Thomas. I'm an assistant professor in the Department of Psychology at Durham University, and I'll be moderating today's Durham RIOT talk. And we're very pleased to have Mark Sabbagh with us here today. So Mark is a professor of psychology at Queen's University. That's in Canada, for those who may not know, and that's actually where I did my own master's and PhD. He specializes in developmental psychology, and his research examines the social, cognitive, and neurobiological bases of preschoolers' theory of mind development, and also how theory of mind skills can contribute to healthy social relationships throughout the lifespan. His work's been supported by, all of the Tri-Council parties here in Canada. And on a more personal note, Mark taught me a lot of statistics in the first kind of couple of years of my grad school education. He was one of my first teachers here, or there, I should say. And so I got to know him, reasonably well over the course of my time there. And he's always been someone I've looked up to a great deal. So I'm really pleased to have him here today, talking with us all about his topic. So before we begin, just a quick housekeeping note. You can feel free to ask questions along the way. Please just use that Q&A feature on the bottom of your screen. And the benefit of that too is that you can also upvote questions that you think are particularly pertinent, maybe echo your own thoughts. And then what I'll be trying to do is look for natural points when Mark kind of finishes up a point to kind of step in and just ask one or two of those questions. I might just answer a few of them myself if they're things I can just address. But also there'll be a period to ask stuff at the end. So without any more preamble, thank you, Mark, and I'll let you take over here.
Thank you very much for that kind introduction, Thomas. I am going to get started, and to begin to do so, I will share my screen. There was a student who asked me the other day whether it's necessary to say that you're going to share your screen, and whether it would even work if you didn't say that. So, and I've never tested it, never tested that question. I've always just said, I'm going to share my screen. And I think that that's part of the magic that makes it happen. Everyone is turned off. And so can you see my screen and somebody like give a thumbs up or?
Yeah, absolutely.
Okay, great. Yeah, terrific, thanks. So thank you for inviting me, Thomas. I'm excited to tell you guys about some ideas that I've had that have been kind of percolating for me for a while. And I'm just going to give you a little background about what raised them for me. I was the editor-in-chief of Cognitive Development, which is one of the kind of main, let's say, specialist journals in my field. And along the way, during the period where I was the editor-in-chief, there was a lot of interesting, there was a lot of discussion and even controversy within my field about what it means to replicate a finding. And so I was thinking about that a lot in the course of my term as editor. And what occurred to me is that we may not, is that the tools that we use to let's say, determine whether we are going to make a claim in the literature or not may not be as sensitive as we think, that there may be a kind of distinction between the strength of the claims we make and the evidence, the strength of the evidence upon which we base those claims. And so what I'm going to just do is talk a little bit about that, talk a little bit about why I think that's true, and then offer an alternative way of thinking about things in hopes of kind of maybe steering at least my own field. And then I don't know if it'll be relevant to other people, but I'm excited to hear whether you think it is, away from this kind of categorical way of thinking about our evidence and more towards a continuous way of thinking about our evidence, especially vis-a-vis its strength as it supports our claims. So I guess one way to start this whole conversation is very grandly by talking about what does it even mean for psychology to be a science? And I think that this is something that I think is an important question to ask, even though I think we all kind of intuitively know what it means to think of psychology as a science. But I think for what it means at a very high level is that we're using a scientific worldview to characterize and explain phenomena in the world. So what does it mean to have a scientific worldview? Well, it means that we're going to have systematic observation, valid measurement instruments. We're going to do hypothesis testing and theory, and that all serious claims of discovery are going to be based on principled inferences that we agree to make based on empirical evidence that we acquire by applying the scientific methods of scientific worldview. I think that's those claims of discovery are, that's what we're sort of out for. And when we publish a paper, I think that we're frequently trying to make claims of discovery or offering claims of discovery. And there are two distinct pillars for this. I'm calling them distinct, even though they are obviously related to one another. One is the criterion we use for determining whether we have a claim to make, and that's the null hypothesis inference. And that's, we have this, we collect these data, and then we have, among the myriad possible explanations for our findings, what we hope is that our experimental design has isolated one in particular, and then elevated it among others. And but then we have this other one, this kind of really fundamental one, is that the differences that we've observed, or the associations that we've observed between our conditions or our independent measures and our dependent measures, well, maybe they're just the result of stochastic kind of processes. And so the null hypothesis inference allows us to rule that possibility out, or we think that it allows us to rule that possibility out. But then there's this distinct one that is what we might call the generalizability inference, which is, if we saw it here, would we expect to see it somewhere else? To what extent will we expect this finding that we received, that we got in the lab, to be representative of some general natural phenomenon that we see? And frequently we just jump right from the null hypothesis inference to the generalizability inference, right? We say like, hey, I got, p less than 0.05, and so this is true. And what I would like to do is, first of all, separate those two claims out a little. I think it's important to separate those two claims out, but also like think a little bit about what this means for us here. So one of the things that this does is it puts us into this situation where somebody makes a claim, and then you go and maybe you try to find evidence that's the same, and you aren't able to do that. And so we call that a failure to replicate. But if you think about it in our context, which is different from other kind of maybe more other scientific contexts like chemistry or something like that, precise replication is difficult, if not impossible, in our field. And it's not even really, if you think about it in a basic sense, I'm not even sure it's typically highly valued from a process perspective. Frequently, we don't ensure that the testing equipment that we use is the same as the testing equipment that somebody else used. We frequently don't ensure that the testing circumstances that we are under are the same as the testing circumstances that somebody else is under. And similarly, and I think, and perhaps importantly here, there are no reagent grade humans. And by that, I mean, there are no pure humans. All of the humans that you test in your lab are going to be necessarily different from the humans that you would test in another lab. And so the fact that, one lab finds evidence for a particular claim and another one doesn't, we say that that's a lack of replication, but I think probably it's more of a lack of generalizability, that whatever you did in your lab is not finding its way over to whatever happened in my lab. And it could be because of testing equipment, it could be because of testing circumstances, but it could also just be, well, your humans were different from my humans in maybe trivial ways, maybe important ways, who knows? But at some level, that's the issue here. And so that replication thing is I've now started to think of it more in terms of like, when we mean replication, what we're really trying to say is something more about generalizability, that when somebody fails to replicate in somebody else's a finding from somebody else's lab, what they're really saying is that, well, I didn't see that with my equipment and my circumstances and my humans. So that's a that's an important thing because it definitely does affect the generalizability of the claim. I'm just pointing this out because I want to take the sting out of that kind of failure to replicate. I don't know if anybody did something wrong in that other case, in the first case that showed the evidence. And I think that sometimes when we say that there's a failure to replicate, we do think that there's a sort of, that there's shame, I guess, a little bit, I don't know, in having failed in that process. And what I want to say is probably it's a little bit easier to think about generalizability, but I think it's really important to think about generalizability because when we are presenting the evidence for our claims, or when we're presenting our claims based on our evidence, we probably shouldn't put them in such strong generalizable terms. So I just put together this very, very simple kind of way of thinking about what generalization means. And I put 2 dimensions, but there's probably more dimensions between the gap between the study you did and the thing that's true out in the world, evidence for the claim that something is true out in the world. And we can have these like paradigm variables, I think. So I put paradigm variables on one axis there, and I put population variables on another one, which is something that's frequently ignored in our field, like famously frequently ignored in our field, these population variables. And so, when we do one study, what we really have evidence is that, the kids, C's as children, I'm a developmental psychologist, so the children in my study did X, but it's a long way between there and children do X. Do you see what I mean by that? There's this kind of difference between what happened in the study and what happened and what's true about the natural phenomenon. And I think we would all agree that in order for us to really say that something's true about a natural phenomenon, we would want to see evidence that it generalizes across relevant paradigm variables, or if it's a real phenomenon in the world, it shouldn't matter what lab you're in. It shouldn't matter what specific participants you have. It shouldn't matter, and it should, and it might vary with population variables, or it might not vary with population variables. Like the extent to which something can be generalized is, how well does it work in my affluent white folks who mostly come to my lab, and how likely is it to also be seen in other folks maybe who are underrepresented in my field. I don't know, but frequently we don't take any of this into account when we're making the claims. We jump right from this kind of like, as a group, children in our study did X to what children do. This was, I'd like to just point to this particular paper here that my friends did, where they talked about this generic language in scientific communication, this generic language. So it's when you say facts as divorced from the context within which they were developed. So we say, what children do as opposed to what children did. There's a subtle distinction there, but it's a really important one. When we say what children do, then that's about what all children will do. We're talking about an essential quality of children. But when we're saying what children did, we're linking it to the episode and the actual data that we collected. What I'd argue is that our evidence is rarely as good as our generic claims about discovery would suggest. And what I would like to talk about for the rest of this is what compels us to think that it is, and how do we do better? I'll pause there for a second. I've only been going for a few minutes, but has anything popped up? Or Thomas, do you have a question or anything like that?
So I don't see any questions yet in the Q&A, but providing this little break period, of course, might spark a thing or two if you want to take a brief pause. I guess just offhanded, in the absence of anything on the Q&A just yet, I wonder what you think of the idea that perhaps part of the reason that we're inclined to use the children do language is sort of concerns that our science has to be viewed as being important on some level in order to sort of secure funding or to have the public take it up and maybe put it into practice. And maybe you'll get to kind of talking about the side of things at some point. I was just kind of curious if you think that that's a factor, and whether it presents any kind of defense for broadening our claims a little beyond what our studies actually demonstrate, if that makes sense.
Yeah, it does. I think that's a really good question. Certainly, I was trained to put things in generic language, to make bold claims. I think it was partly to, yes, I think the feeling is that pushing bold claims furthers our field, or furthers our thinking in the field. It sparks debate. It does all of these great things. I think the question is how productive that is when we have, the sort of, and to what extent it may be that very thing that is contributing to what we're all now seeing as this kind of existential crisis in the field about the replicability of findings. And you could say things like, well, if you make a weak claim, then it's never going to get picked up in the press. Well, it's probably good if your weak evidence doesn't get picked up in the press, especially if you're doing something that's clinically relevant. If you have weak evidence that some intervention is effective, that may not be something that you want to share until you have stronger evidence.
We do have a question in the Q&A.
Sure.
So someone asked, how can we stop newspapers distorting science? So in other words, how do we prevent the press just doing this of their own accord, even if we're quite reasonable in our presentation of facts?
Yeah, well, that's a great question. And I think that that's what I'm going to try to say is that I think one of the things that we need to be is reasonable in our presentation of our evidence. And we need to have norms and standards that are easily understood, not just by us, but by anybody who's here, who's, what we, stakeholders in our field, which is the public, right? Like the public is stakeholders in our field. And I think that we, by using the language, and I think also a misunderstanding of our statistical methods is what compels people to, compels the press to pick up on claims and perhaps make more of them than we would even feel comfortable with. But also people vary. I think us researchers, we vary in how comfortable we are with making strong claims in the press. So I think that that's an important thing. Yeah. And what I'm going to talk about a little bit in the second part here is about how we might do better. Great question, though. That is such an important thing.
I could throw another question out, but if you want to continue, then that's...
yeah. Why don't I? Oh, well, go ahead. Yeah, go ahead.
Okay, I guess it's more of a comment in a sense. So I know one thing that sort of happened somewhat recently was there was an attempt to look at the bystander apathy effect using real world data, where they actually kind of looked at CCTV kind of footage actually from a variety of different contexts, and were quite disappointed that they didn't find any evidence of bystander apathy, but almost seemed to find the reverse. And so I kind of wondered if maybe part of the problem, sort of apropos to what you're saying, is that we make these big claims and they all make sense within laboratory context or within the constrained circumstances in which the studies were done, but it actually sets us up for public disappointment and even shaming when it doesn't actually work out that way in particular real world circumstances, and that the papers didn't tell you it wouldn't go to, if that makes sense.
That's right. That's right. When we reify claims like, oh, well, there's the bystander effect or something like that, when we bystander apathy or something like that, diffusion of responsibility, when we reify them in these ways, I think that that is a further step in the genericity of them, the generic in establishing the generic nature of them. We posit them as extant, and thus makes it kind of seems actually irrelevant to do more work on it when it's a thing. It's already an established thing. So I think that that's another way in which, when we forget about the importance of, actually what it really takes to establish evidence for a generalizable claim, then this is exactly the kind of thing that might happen. Yeah. I'll move on. So basically, I think that there's a main, I'm making this sound dramatic. It's not dramatic, but there's a main villain in our process here, and I think it's null hypothesis significance testing, and not necessarily how it, not the things that we do even necessarily with it, but rather the inferences we draw. When we have null hypothesis significance testing, we basically establish some sort of alpha criterion and then we say, you know, as long as our evidence reaches that single criterion, then that's our point for making a discovery. So, and we reify that criterion. We treat it as not just a sort of like a sociocultural convention that we've all adopted as researchers in psychology, but we actually treat it like an ontological boundary. So you've all had this experience, right, of, you know, you've run your analysis and it comes out at 0.06, and that is garbage. But if it comes out at 0.04, well, then it's gold. And so we treat it like you know, like 0.05 is this portal that we walk through. On the other side is a gorgeous kingdom of milk and honey, and on the other side is a decrepit, you know, Soviet nightmare or something. I don't know, just thinking out loud. This, you know, I don't think that this comports with how we, you know, if we were to give it any thought, I don't know if we'd really, if that view, that treatment of 0.05 as an ontological boundary is one that we would, you know, explicitly subscribe to, but it surely is one we implicitly subscribe to, I think. So, I just found some memes online that kind of, I think that they're just made by students in stats classes, probably as an assignment. But there's Cy, you know, with, you know, the world's exploded behind him, and he's triumphant after achieving P less than 0.05. There's another one here, somebody who doesn't achieve 0.05 needs obvious comforting. We're preparing for Halloween here in North America, and there's scary things, and nothing's more scary than P equals 0.06. So even though there's no ontological significance to 0.05, we guard this boundary fiercely. There's another meme here about 0.05. And chances are each of you have probably had at some point some sort of argument with a colleague, I don't know what side of it you were on, about marginal significance. You know, when somebody says something like, you know, if it's like between 0.05 and 0.1, they say, well, it's marginally significant, and you've been on one side of that, either fiercely defending 0.05 or not. I think that reifying 0.05 and treating it, at least implicitly, as an ontological boundary has really, really important consequences for how we understand the evidence that we collect in the studies we run. I think that this is really evidence in this phrase that we've all probably used when we've been talking to our supervisors or friends or colleagues about a particular study that we just completed, and that's whether the study worked or not. My study worked. And so what does it mean for a study to have worked? Well, for a study to have worked, that means that the results you obtained, the effect that you assessed, or your estimate of the effect, allowed you to make a claim that it wasn't related to chance or something like that. That it, you know, that the effect you obtained, the estimate of the effect you obtained, exceeded 0.05, and that's what means it worked. Why do we say that that's what it? Why do we say that that's what your study worked in that case? Like, what worked about it? And I think that it all comes down to this, our understanding of, or at least implicit understanding of, the Klein thesis. You may all have come across this in some of your stats classes, or if you did philosophy of science class. The idea behind the Klein thesis is that when you're testing any target hypothesis, you don't test it in isolation. Instead, you test it, you have all these ancillary hypotheses about the validity of the methods that you're using, the measures that you're using, the appropriateness of the statistical procedure, and so forth. And the Klein thesis is that everything has to be accurate. All hypotheses have to be right in order for your target, in order to get evidence for your target hypothesis here. So if we gain evidence in support of target hypothesis, then we think that the target and all of the ancillary hypotheses are correct. And that's what we mean by our study worked. And then if a study doesn't work, well, it could be that either the target or one of the ancillary hypotheses are wrong. So that, you know, you were wrong in your guess about that. And what that means is that you know, if it didn't work, then you can go back and you can consider either your target hypotheses or any of your ancillary hypotheses. And I think that this is essentially what we do when we engage in what we call p-hacking, right? So when we're doing p-hacking, we collect and analyze data. Like, this is something that would happen in my field, right? You know, I collect kind of two, experimental and control group, and I might have like, I don't know, 20 participants per condition here. And I analyze the data that I get with the t-test. And usually I just have, they complete a battery of tasks. Maybe they can score from 0 to 4 on it. Complete a battery of tasks. And, I get the t-test results and it comes out at 0.08. It didn't work. But then let's say I think, maybe I violated some of the assumptions of t-test. Maybe that wasn't the right test to use. Maybe I should reanalyze that same data with a non-parametric equivalent like Mann-Whitney U, and then lo and behold, it turns out. So I report the discovery with U, and I reason that the non-parametric approach must be the appropriate one because that's where my study worked. That can usually be supported with some sort of sensible rationalization, like, oh, well, I was using these count data and, they're not normally distributed. And so really, and if I go and look at my distribution, it's bimodal and whatever, I can do whatever. Of course, I do like p-hacking is bad, and it does reflect a logical error, right? True effects measured, the logical error is that we think that true effects measured appropriately, inappropriately designed studies are likely to cross 0.05. And so anything that crosses 0.05 must be likely to be a true effect. I think that's the logical error that we're making. We assume the symmetry there, which I think is encouraged by reifying 0.05 as this portal that we walk through, on which side there is, real things and not real things. And I think that p-hacking is, in my view, likely due to this logical error way more than it's likely due to any kind of, that's promoted by treating 0.05 as an ontological boundary, and not due to like statistical malfeasance or people just trying to get something published or anything like that. I believe that it is an earnest error that's based on this kind of thing that we do, at least implicitly, which is treating 0.05 as as an ontological boundary. There's been a lot of discussion about p-values and whether they're valuable and what they mean and everything like that. And there's a lot of people who say that, well, what we should do, we shouldn't just report p-values, we should report effect sizes, we should report confidence intervals, maybe we should change our criteria to these things. And I don't think that any of these things are bad to do. Like, go ahead, you should report effect sizes. One of the most interesting things that probably in your report would be the effect size. I mean, it is an interesting thing. I think that it's fine to report confidence intervals, but I would like to emphasize that none of these changes solve the problem of treating about, having a categorical boundary at which point we claim discovery. None of these solve that problem. Reporting effect sizes does not solve the problem. In fact, in my field, even it's worse. Sometimes people will report a non-significant effect size or a non-significant result. They'll report, p is like 0.1, but they'll say, but my effect size was huge, so it's probably real. And the effect size is, anyway, it's a real problem because they're answering different questions. The p-value is more about, the location of that effect that you observed within the null hypothesis distribution, whereas the effect sizes are just a descriptive statistic of how big the difference was. So, and at low ends, which is common in my field, large effect sizes are common at low ends, or can be seen by chance at low ends. I think that equally important is that treating the 0.05 as an ontological boundary also compels us to treat all evidence in support of some claim as of equal strength, garbage or gold. And this, I don't think that this actually comports with our real world intuitions about p-values or the strength of our evidence or anything like that. We've all felt a lot. I think that when I'm analyzing data and I'm following the normal procedures, I feel much more comfortable about findings that are significant at a lower p-value or that are associated with a lower p-value than I am about findings that are associated with a higher p-value, whether it's significant or not, whether even when both cross the significance boundary. And I have this quote from Rosenau and Rosenthal here. They had this American psychologist paper several years ago where they took this up, that we only wish to emphasize that dichotomous significance testing has no ontological basis. That is, we want to underscore that surely God loves the 0.06 nearly as much as the 0.05. Can there be any doubt that God views the strength of evidence for or against the null as fairly continuous function of the magnitude of p? So I love that. So there's another opportunity for pause, and I see that there's some questions that have popped up, so I'll see what I can do.
Yeah, absolutely. So I'm probably going to just address the Q&A more in the order of like how relevant it is to your current point in the discussion. So if I'm not bringing up a question, it's more because I suspect you'll get to that direction later, and maybe it would be better for the question then. So the one that I think is most maybe appropriate, given your point about the boundary of that P05 poses. So one person asked, can it therefore be said that open science would avoid p-hacking, help solve the replication crisis, and aid the journey towards increased generalizability and reliability? I think in part asking, given your points here about the magical 05, what is the role of open science maybe in helping to address that, if any, in your view?
Yeah, I mean, I think open science is great. Obviously, I mean, we should have open science, and we should, and a lot of the efforts that have been made in open science are terrific with respect to, for instance, I think what the question asker is asking maybe about is about like registered reports, right? So pre-registration is nice, but unreviewed pre-registration, I have found in my journeys as a editor or reviewer of papers that unreviewed pre-registration does not a good paper make. So you can pre-register something that it's poor, that reflects poor statistical thinking, that reflects poor design, and the fact that you pre-registered it does not make it good. So I think that reviewed pre-registration is terrific, in the form of registered reports. And I think it's especially terrific for what we might think of as mature sciences. So if you are thinking about, if you're doing an SRT type of paradigm where it's pretty well known exactly what kind of data you're going to get and exactly what an outlier is going to look like, and exactly, you have all of these tools at your disposal because you're building on a massive science, then terrific. Then it is exactly what you should be doing. I'm not as convinced that it's as feasible at this point for like my field, because there are very few paradigms about which we know as much as we know about SRT, for instance. So I think that for me, the key is making sure that we make measured claims that reflect the strength of the evidence, and that reflect the extent to which we have evidence about its generalizability before doing all those things. So I guess at the end of the day too, and maybe this is controversial, I don't think that open science solves the ontological boundary problem, because if it's all using the same ontological boundary, then, Jill, who I noticed is in the audience, Jill Jacobson, she talked to your group about what it means to replicate a finding. And I think that that's a really super discussion, because it really kind of points to how difficult it can be to, when we have this ontological boundary, one person claims, oh, well, children do X, and then somebody else just falls on the other side of that boundary and they say, well, no, children don't do X. And, I guess we could, if in the open data sense, we could like maybe accumulate all those data if in fact they're collected in comparable circumstances, or we can do MIDI meta-analyses and things like that to try to get evidence on it. And I think that all of that's, valuable. And, we ultimately do want to get these effects. But I think that, one of the things that, so now I'm going to start going a little bit on a tangent here, and it is something that I'll come back to. So, but I just want to say, like, if somebody makes a claim and it's on the basis of weak data, and you know it's like transparently on the basis of weak data, or a weak finding against the null anyway, that should affect your desire to build on that finding, to replicate that finding. It should do all of those things. And I think that that's actually one of the really important things, is that if we are just always chasing claims, irrespective of how strong the data are for them, then I think we wind up potentially down expensive blind alleys. I guess that's one of my concerns there. So I think that open science is obviously the way to go, but I don't think it solves problems entirely.
Just a different question from the Q&A, will be a little bit of a change in topic. This is going back more to the point about differentiating between replication and generalizability. So Maya was asking, I have a concern, some people may use this argument to defend that their effects do exist, albeit they are not as generalizable as previously thought. I think she means in the context of like a non-replication, and then they might, continue getting grants for work, getting public money, et cetera. And the example is given of the new failed replication of ego depletion, which may now be the third. What would you suggest to do in this situation where it's used as a kind of a defense to continue to study something which one might argue, I'm not taking a side, that the phenomenon doesn't exist and should really stop being investigated? I hope I'm not putting too many words in that.
No, that's a great, that's a great question. And there is this kind of, yeah. So I don't know the specifics on the ego depletion stuff. I do know that it was a target of, I think Data Colada IR at one point, which I think it was, interesting, because, what they found in their, I think, to summarize what they found was that almost all the effects are weak, or rather, not that they're weak effects, but there's weak evidence for those effects against the null. That almost all of them were kind of near 0.05. And so when you do those funnel plots of the p-values, there was way too many that were too close to the boundary, right? And so, so what if they had, and so they're saying, well, we found it, and I don't think they didn't find it, right? I don't think they didn't find it. What I think that they found was, it was just weak evidence. And I think that they probably conducted their studies, they designed their studies to find weak evidence because there was a focus on moving fast and doing these things in that way. And so I think that they did find it, but it lacks generalizability, right? And if there was a way to talk about the fact that if they had to report in every paper how strong the evidence was for the effect, then I would have concerns as a reviewer that that they keep building on weak effects rather than trying to get strong evidence for even one of these effects. So I would have concerns about that. I would not continue to give those labs grant money, or I would, but maybe just less or something. I don't know. Like if they're working on interesting problems and doing that. I think that hopefully what we're all interested in is generalizable findings. I mean, I hope that that's what our collective science is working toward, and that we would prioritize that in this, and not simply kind of like it seems of not so much interest that one lab continues to find something that doesn't seem to be found anywhere else. Does that make sense? I'm sorry, I kind of rambled a bit.
No, I think you addressed the question there. Just one quick note, Jonathan, or John, sorry, I'm not sure if you were trying to say something, but just, your audio is on. So if you were not looking for a chance to step in, then you might, okay, cool. I guess that answers that. There are a couple other questions, but I feel like maybe they make sense later, given what you've already foreshadowed you might get to. So maybe that's good for now.
Okay, happy to do it however you like, I am going to move on to my dumb proposal now, which is that we develop a conventionalized qualitative language that allows us to talk about the strength of the evidence versus the null hypothesis in favor of the claim that we hope to make. So when I started thinking about this, it was around, so it was a long time ago, and it was around the time when the folks at CERN were working on the Higgs boson stuff. So there was all of the excitement about Higgs boson discovery, and so these are very expensive and intense experiments that they have to do, and they do have this signal to noise problem that they need to solve. And so an interesting question is how, at what point do they think that they've got a claim that they can make, that they have a discovery that they can make? And in physics, and what was really interesting to me is that we were getting, I don't know why there was so much media attention on this, because almost nobody knows why it's so important, but for some reason, we spend so much public money on this. It's amazing and terrific. I mean, I love it, but it's a lot. And thousands of people working on it, thousands of people invested in this. And, they get their first round of data and they go to the lab and they process it, and then they come back and they say, yeah, it's not conclusive. But, people are kind of like hanging out in the hallways going, yeah, it's probably there. It's probably there. But the official word is, we don't know. It seems like it's there is what's happening in the hallways. And then they do another round of data and they're like, yeah, we're pretty then they have this like press conference where they say, we're pretty sure it's there, but we cannot yet claim a discovery of it. And then finally another round of data, and then they're able to finally say, oh yeah, there's a discovery. So what prevented them from making the discovery? And it's because they have a very strict criterion for claiming a discovery, claiming a natural discovery, a discovery of something that's true in nature. And that's what they call the 5 sigma boundary. So the signal has to go outside of the noise by 5 standard deviations. So for us, that would be, basically equivalent to having a z-score of 5 or greater before we would make a claim of discovery. It's not that they don't report findings in journals that don't make it to 5 sigma. It's just that they only will claim, do this big kind of event of claiming a discovery once it gets to 5 sigma. And what I hope, I don't think that that's reasonable for us, especially for our young science, our young and complicated science, complicated by the fact that we don't have reagent grade humans. But what I would suggest is that we may choose to have a high discovery boundary, but we might have other ways of presenting our evidence, even if it doesn't make it to discovery level, even if it's not decisive against the null, it may still be valuable to let people know about. And I'm going to call my approach trivially Bayesian, because it doesn't rely on this kind of frequentist long run p less than 0.05 thing. Instead, it kind of tries to quantify the strength of the effect, but it's trivially Bayesian in that it doesn't, I mean, it can, but it doesn't necessarily involve characterizing the distribution of your alternative hypothesis and things like that. So you all probably know about this because you're all interested in this sort of thing, but a Bayes factor is where we try to quantify the evidence in favor of the null hypothesis as a ratio of how likely it is following the data, how likely your alternative hypothesis following collection of your data, as a proportion of or divided by, I guess, how likely the null hypothesis is following a collection of your data. And so this is a very trivial kind of computation that you can make. And normally if you get a Bayes factor, it's about 3, if your null hypothesis, or if your alternative hypothesis is like 3 times more likely than your alternative hypothesis, then you wind up saying, okay, well, I've probably got something there. A lot of us, so the regular Bayes factor requires precise specification of an alternative hypothesis, which a lot of us don't like to do, even though we've got accustomed to doing it in the null hypothesis testing context. significance testing context because of power analyses. So we all have kind of estimated what sorts of effects we would see. And we could make a guess about their likely distribution, but we don't love to do it for whatever reasons. We could talk about that later. Recently, about 5 years ago, statisticians who were engaged in this big long discussion of the p-value and maybe alternatives to the p-value offered an alternative to that, which is this, what they called the average Bayes factor, where it represents an upper bound on the Bayes factor given all reasonable alternative hypotheses. So integrating across all reasonable alternative hypotheses to provide an average estimate of upper bound on the average estimate of the Bayes factor. And the great thing about it is that it can just be based on the p-value. So I'll get to why that's, interesting. But just to let you know how it behaves, so I've plotted Z on the x-axis there, and then there's B bar on the y-axis. You can see that the scale of the y-axis is massive, because once you get to about 3, Z equals 3, B bar starts to go up like crazy, starts to really go up. But so in order to show you what's happening down a little bit lower there, I said what's happening up to 3 in that second graph down at the bottom there. You can see that as Z goes from 1.5 to 3, B bar goes up. Goes from about 2 at 1.5 to about 30 at close to Z equals 3. So here, what we're saying, so just to be clear, what we're plotting on the y-axis here is a sort of average Bayes factor, the average, the extent to which the data are favoring the alternative hypothesis relative to the null hypothesis, averaged or integrated across all possible all reasonable, not all possible, all reasonable alternative hypotheses. And what, and so what we could, so this is a different way of thinking about, a different way of quantifying the strength of our evidence here. And, what we could do is we could always use one-tailed t-values when relevant, or if you're using F, then they're always one-tailed, or one-tailed test distributions, they're always one-tailed. And you use p-values to obtain a more, oh, sorry, this slide's been edited, but basically we can interpret these Bayes factors on a leveled kind of way, and we can characterize them however we want. I'm offering this potential as a, to get the ball rolling on this. We could have 6 levels of them. We could characterize them in these different ways. This is something that people have tried. Bayesian, people who have really advocated for a Bayesian analysis have tried something exactly like this. They typically don't get as high in their B bar in the B as I'm suggesting we could, based on these distributions here. But this is what I would suggest. So, you could have some very weak evidence, or you could have some decisive evidence. And what I'm proposing is that when we write our abstracts, we found weak evidence in support of this claim. We found strong evidence in support of this claim. We found moderate evidence in support of this claim. That's how you would talk about it in there. And so you could ask, and maybe some of you are thinking this, why would you ever report weak evidence or anything less than decisive? Why would we ever, why can't we just decide what's decisive evidence, treat the rest as noise, and then just go with this decisive stuff? Wouldn't it just be better to keep it to yourself? Well, I don't think that would be good for our science, especially as a young science. I think that reporting of weak evidence could be really relevant to folks in your field who are working on similar issues, might mitigate some file drawer problems. We can, if it's weak evidence, it might contribute to a cumulative estimate of an effect. But more important, I think that if we always relied on having decisive evidence, there would be 2 things that would happen. One is that we would only test for effects where we could obtain very, very strong evidence. So that would really guide researchers in the decision making that they're making. And in a lot of contexts, and in particular my own, which is probably why I'm really, really against this, decisive evidence would be really hard to obtain. Like, I don't know if who the developmental psychologists are out there, but sometimes it takes me 60 hours per kid to collect data from them after all the different coding that we do and all the different and all the efforts that we have to recruit them and everything like that. Having 20 subjects per 20 participants per group is sometimes good for me. Sometimes it's good. And I may not be able to get decisive evidence, but I might be able to contribute to the scientific discussion with moderate or even weak evidence on a particular question, so long as that question is one that's really important to the field. Another question that you might have is if B bar is just a conversion from p-values, is it any really different? And the answer is no, it's not, I don't think. But I think that it's important that we move towards a different metric when thinking about how to characterize the reliability of our findings, partly because of the sorts of things we often see in the press about how p-values are misrepresented. Frequent conflation of a particular test p-value with alpha makes interpretation of p-values a lot less straightforward. So, no matter what your p-value was, your test probably had, alpha was probably 0.05 in your study. And I would just add that I don't think the point here really is to have different statistics. It's rather to develop a system that moves away from that categorical, that helps us to move away from that categorical way of thinking about our evidence, that portal way of thinking about our evidence, and more towards a continuous strength kind of model. Oh, I see we're running late. How much time do we have, Thomas? I'm sorry. Do people leave it?
Ordinarily, it's sort of strict. It's sort of informally structured around an hour, but it's totally fine to go over. And you do have some questions and stuff. So if you're comfortable,
why don't I take some questions? I'll take some questions. I have some other stuff to talk about, but I can also stop at any time. So I'll take questions.
Okay. Sounds good. So the first one, probably the most directly relevant to what you just said. Jill was asking, so in the p less than 0.005 paper, they suggested other labels for p-values between 0.005 and 0.5 to still encourage reporting results above the new 0.005 threshold. Have you compared your category / labels to theirs to sort of see how they look in a comparative sense?
Yeah, that's a great question. I shouldn't. I haven't, but I will. I think that's a really important point, that this is not what I'm suggesting here, that labeling the strength of evidence is not particularly new. I do agree with that. I think 0.05 is probably still low to call like discovery zone, or not low enough to call discovery zone. So I have a particular kind of small thing with that. But I will note that on that paper, there were a lot of Bayesians, right? Like Zoltan Dinas was on there, and there were tons of Bayesians that were on that paper. And I think that's sort of why it's like, look, not all evidence might be that great, but maybe if we had some way of talking about the alternatives, then that would be really good. I think so I agree with that. Yeah.
One other question, perhaps you can connect it here. So one anonymous person asked, how can we communicate scientific results to a layperson without distorting the findings of our study and overgeneralizing and such? So I wonder whether that could connect to what you're talking about, in the sense that, do you think this could be language we use for the public as well, kind of like your physics example?
Yeah, I think what I hope we move towards is, vis-a-vis science communication. I think that we're all really excited about, telling people about discoveries. But I think one of the things that captivated the public so much about, say, Higgs boson was not so much the discovery, but rather the process of discovery, like how important the question, all of the work, all of the press, and there was a ton of it leading up to it, was how important it is to show this thing. How important is it to know this? And how much progress have we made on it? Well, we've made a little bit of progress. These people have done a little bit of work. These people have been, and when we do that, it turns it more into a story about cumulative science rather than, star researcher in star lab showed, discovered that X was true. We still kind of do that a little bit more, and I wish that we were thinking of things more in terms of the process and how interesting our questions are and how important it is that we find out right answers to our questions, not so much why it's important that researcher X found that Y, if that makes sense. So that's how I hope that the narrative will change about vis-a-vis scientific discovery, that we'll start to think more about why it's so important to understand X, about why humans do the things they do, and the scientific journey that we take in order to kind of characterize those mechanisms, rather than oh, look at the cute thing that, the sort of what used to be the model at Psych Science. I don't think it is anymore, but ooh, here's something cute that humans do, p less than 0.05.
I have another question. This one's from further back, I think. So I think this might have been in response to when you were saying that you'd been seeing pre-registered studies that had not been reviewed. And so you found that often those pre-registered studies were just as problematic as a study that hadn't been pre-registered. So one individual was asking, if we want to peer review every proposed study as well as every published work, do you think that artificial intelligence or something like that could be used to make the assessment of validity and to sort of, because obviously it's quite time consuming to
Interesting. I've never, that's a kind of, that's a left field question for me. Yeah, interesting. I don't know how one would do that. I think that the idea behind registered reports, of course, is that you don't wind up reviewing the paper, the publication so much. You do that most of the review work is done up front, and then there's a second review that's done later. So maybe it's not quite as serious as the questioner was suggesting, but I still do think that, that's really important. Interesting to think that there's some sort of way of scanning the text to say they don't know what they're doing.
Scanning the text to see if it contains the words manipulation check.
Right. Okay, if it's not there, you're done. Love it. Super interesting. I would be really curious to think about how you would do that. What would be the sort of cluster of things that sort of correlates with bad? I don't know. It'd be interesting.
I think that was it for open questions.
Okay. Yeah. Should I do you want to hear more, or does everyone want to go? It's all right if you need to go.
I mean, I'll happily stick around. We still have most of our participants. A few people dropped off, most didn't. So if you want to continue, I think you'd be fine too. But I understand if you have other time commitments.
No,
too.
I'm fine. I'm fine. Thank you. So I just want to talk about this reconceptualizing replication kind of business. I think that, and this kind of comes back to stuff that you've already heard about from Jill, so I won't go too much into it here, but categorical boundaries make it unclear how to conceptualize what it means to replicate findings. And I think that, we don't really have a clear way of flagging in our reports, which are focused on categorical claims, on strength of evidence. And so, it's hard for us to kind of just judge whether it's worth thinking about replicating a particular finding. And I just wanted to give this example of one that was in my field. I don't know if I need to go too much into the details of the study, but Kylie Hamlin and Karen Wynn did this really neat study where they're really interested in infants and their sort of early social cognitive abilities, and in particular, their ability to map if somebody acts in a way that's socially undesirable, do they then go on to see that person as less desirable as somebody who acts in a more desirable way? So what they typically do is they'll see somebody or something act in a mean way towards something else, and then the other person will act in a nice way towards something. The other entity will act in a nice way towards something, and then you just put both of those things in front of the kid, and then they will at some point reach out for one of those things, and then you can look to see whether they have a preference. That is to say, whether they are more likely to reach out to the helper, the nice thing, or the mean thing. And what they've found across several studies is that babies tend to show a preference for the helper, that they tend to, if they, when you know they first reach out for something, they tend to look out for the helper. And Salvatore and colleagues came along and they wanted to sort of replicate this. And what they did was they did the exact same thing. They ran a few more subjects. So the first study, the initial study had 16 subjects, and then the second study had 24 subjects. And what they did is they looked at the number of babies who were showing the preference for the helper. And they found, so Hamlin and Wynne claimed on the base, so what these circles represent is every participant, and where I've filled in the participant, that's the number of participants who showed helping, so, or who showed the preference. So the red dot is over, I think, like 12 in the Hamlin and Wynne, and it's over 15 in the Salvatore et al. But because of their differences in their sample size, one crossed a boundary and the other didn't cross a boundary. And there's this big hubbub in the field. Why did Hamlin and Wynne find X when Salvatore et al. Didn't find X? So, and Salvatore et al. Then did a second paper or a second study where they manipulated all the things, and there was this long conversation with Hamlin and Wynne about what they needed to do differently in order to show the effect. But what I would say is that if you look at the data closely, do we really think that they didn't find about the same thing? Like, if only one other kid didn't show the preference, then their data would be almost identical to the Salvatore et al. Data. If Salvatore et al. Had just found 2 additional kids who did show the preference, then their data would be identical too. So in some ways, what I feel like what should have happened in the beginning was Hamlin and Wynne should have said, we have weak evidence for this. And Salvatore et al. Might have said the same thing following their analysis. And in that case, we would have had replication, although I doubt that Salvatore et al. May have even bothered, because, if Hamlin and Wynne wanted to, believe that this thing is true, but they only found weak evidence for it, then maybe they would go track it down with stronger evidence. But what I want to say here, I guess, is that so much time and effort and energy and money was spent on the Salvatore et al. Replication, and so much anguish for the Hamlin and Wynne paper about whether or not their study replicates, when if you look at it, it's really just not that different. And I feel like the reasons that they felt like it was so different is because the boundary, the ontological boundary, treating 0.05 as an ontological boundary, made them make different claims. So what I hope to is that, so that's, I think, one of the potential benefits of this. There's a handful more, I think, of doing it. One is that, if you think that something is really important and you would like to get strong evidence for it, then knowing that you need strong evidence for it in order to make a strong claim might incentivize collection of better evidence, for findings that are really, really important to you. So instead of just being satisfied with weak evidence because it happens to cross some sort of arbitrary ontological boundary, we might incentivize collection of more better evidence. Finally, we could have, it would focus resources, so in developmental, we have this Many Babies project spearheaded by Mike Frank at Stanford, where some of the more interesting and important findings in our field, where there's a lot of controversy, are getting a multi-lab treatment right now. And then I think finally, this would just help us make better decisions about how to build. Like if I was a graduate student and I was really intrigued by some finding and I brought it to my supervisor, and my supervisor said, yeah, that is kind of intriguing, but where should we go from here? They only had weak evidence for it. What should you do? Like, do you feel like that's a strong basis to build upon? You might say no. Anyway, that's it. Thank you.
Yeah, thank you. Thanks very much, Mark. I just realized I wanted to make sure I got to it. There was a question someone had put in the chat. I just overlooked it because it wasn't in the Q&A. My bad. So this was from Lori Bevan or Bevan. The replication issue has plagued psychology for some time now. How do you think we can best incorporate the issues of p-hacking, the ontological boundaries we've set, and the issues of results being unreplicated while keeping to the values of the scientific method?
Yeah, so I think that's exactly what, I mean, that's what I'm trying to offer here. I think what the solution that I'm trying to offer here is one that allows us to do that. So just as we are careful in how we conduct our studies, and we try to ensure, we do everything we can to ensure methodological rigor, measurement validity, all of these sorts of things, I think we should also be upfront about how strong our evidence is, and in support of a particular claim. And so instead of making strong claims based on weak evidence, we should make only weaker claims based on weak evidence, and then save our strong claims for stronger evidence. And I feel like that is a more scientifically responsible thing to do. And make space for, I think that it's important to make space for weak evidence, but it has a space that's separate from the space that we use to talk about the real true stuff in our field, the stuff that we feel like there's a strong enough evidence base that we can say it's probably true. I don't know if that answers that question. That was a complicated and really good question. And
yeah, it was a fairly broad question, and also the individual who asked it just mentioned that it's partly the problem is that they'd asked it before, and you kind of did get to it, so it was a timing issue on my part. If that makes sense.
Got it. Yeah, got it. Yeah.
Hey, Mark. So I can't put the Q&A as a panelist, so I'm just gonna ask you if that's okay. Yes. Very interesting. Yeah, very interesting talk. And I just wonder if you think that this connects to the whole conversation around how, at least in the social psychology as a subfield, we kind of obsessed with theory, and how like every time we have a paper that published, and it's just all is, we have a lot of mini theories in psychology. Whereas would you say that from what you have talked about so far, it kind of made me think about this idea of pushing for more descriptive findings in psychology. So where every time we publish a paper, we should just describe whatever sample, that's what happens in that sample of babies that we just collected data from. We're not trying to make a theory of all babies. So do you think that can connect to that conversation between,
Yeah, that's a really good point, because I think that, a study is only worth doing, probably, right? A study is only worth doing if it's theoretically interesting, relevant, right? That it's addressing some sort of question that emerges from, or testing some prediction that emerges from some hypothesis that we think is an important one, right? So we wouldn't want to say that we are kind of, I think it's fine to be, as you put it, obsessed with theory. I am for that. But I think that you're right, that we need to recognize I think that if we recognize the limits of our evidence that we obtain, right? So it could be that you find knockdown, drag out, decisive evidence in favor of the mechanism that you're working on. And then, then you have to do further experiments to rule out alternative hypotheses and everything like that, right? Like there's a lot of stuff that you still need to do, but at least you have knockdown drag out evidence on that one particular paradigm that you used. That's possible, but it's also possible that you don't have that. And so that's what I mean by this kind of like building, like how important it is that this is all part of the process, that, I didn't get knockdown drag out evidence. I didn't get decisive evidence with this particular paradigm. How important is it that I do get decisive evidence with this paradigm? Do I want to try another paradigm where I would get decisive evidence? Or what do I want to do? Where do I want to go from here? And I think that there's lots of different opportunities, but no one of those studies is going to take you to that full generalization claim that is the real sort of claim that you want to make on the basis, that on the question that came out of the theory, right? I think that's, that more work needs to be done. No one study is likely to be, even if it has decisive evidence for an effect in that paradigm, it's probably a long way away from decisive evidence, from this kind of generalizable characterization of a generalizable phenomenon, evidence of that you've characterized generalizable phenomenon, because that still has all those other steps in it. So this is just one part of that process. And what I'm I guess this is what I was trying to say at the beginning, is that we shouldn't assume that when we walk through the door to 0.05, we've now got through that, and now we can just generalize to our heart's content. Like, any finding that you get is going to be local to the paradigm. And once we stop reifying 0.05, I think it'll be easier for us to just kind of cognitively conceptualize that.
Yeah, I have a personal experience with this, in that my master's thesis involved replicating and extending one of the foundational effects in attitude psychology, Timothy Wilson's introspection effect. And we collected 2,000 people and managed to not get the effect at all. And we think we know why it didn't happen, although we haven't been able to chase it. But basically, it was just a procedural change. And so it's funny, because I go back to Wilson. He actually does an internal meta-analysis of which when he actually opens his file drawer and reviews all the data, and he gets a p-value of 1 in a billion or something. Yeah. And I throw thousands of people at it and can't get the effect because I just made a small tweak. And all of a sudden the effect is literally entirely eliminated, which I think is just one of those examples of generalizability, and that's strong evidence not necessarily promising generalizability.
Right. But
small enough about
the paradigm. Small tweak.
Enough about me. Someone else had a good question.
Small tweak, but yeah.
One other question from the Q&A. So in general, all of the discussion has, of course, kind of focused on quantitative studies. What about the qualitative set of studies and its integration into mixed methods? Is it just to add quality, or do they have a more significant role in terms of balancing the scales, such as, against p-hacking?
Super interesting question. I'd have to give that a lot of thought. I'm not an expert in qualitative methods at all. See their importance. I'm typically one of these kind of jerks, really, who's like, well, qualitative evidence is good for generating quantitative hypotheses or something like that. But I've totally come around on this. I've totally changed how I think about this now, and I am now very much for better understanding the role that qualitative evidence plays in in conceptualizing natural phenomena in psychology, right? So I'm totally for it. I'm really excited about thinking about that. I think the challenge is, when we take these kind of part of what I think it means, at least from a folk scientific perspective, when we say we want to have so these are just random thoughts I'm having, or I've had, is that when we take this kind of folk scientific perspective, I think one of the things that we mean when we're saying we're science of psychology people is that our subjectivity doesn't matter so much, and that whatever we do and wherever we do it, however we apply these measures, then we should see them, and it does have this kind of reagent grade humans kind of assumption built into it. And I think one of the things that's really interesting about and challenging for that, qualitative methods reject both of those claims, right? They recognize the subjectivity of the researcher on the one hand, and they recognize the idiosyncrasies of any given participant in there. And so here the question is not about generalization, like, at all, right? It doesn't have that same kind of focus. So what I wonder is whether there might be even ways, and I think that this is what the question is getting at, about how we can blend these two things to make sure that there's a sort of like meaningful reliability or face validity or something like that to the phenomena that we get this kind of scientific evidence for, or this kind of more quantitative evidence for. I'm super interested in this question because you know, I think that there's a real tension there in the field, and I think that it's one that we would do well to resolve. Thank you for that really interesting question. Thank you.
One quick comment for me, reagent grade human, is that your own expression? I quite like it. I'm just wondering if I can use it in the future.
Yeah, I made that up. But I mean, I maybe other people have made it up too. But reagent grade humans is not a thing.
There is an additional question here.
Yeah, shoot.
So how can we use, how we use findings really matters. I guess it's more a comment. How we use findings really matters. If someone finds P equals 0.7, additional 500 milliliters of water drank each day reduces risk of cancer, then I'm just drinking the water.
Sure.
So I guess
sure. Like it doesn't matter if it's great evidence for it, as long as it's like a, you know, minimal intervention, and like you don't care if there's great evidence for it. If there's any evidence whatsoever for it, then you might as well do it, right? So, you know, but like I kind of want to know, like, I guess if I read that paper and or somebody told me that, if I read about that paper in a news outlet, right? I might want to know that the evidence for it was weak. I might still decide to drink the water because, like, hey, smart plan, like low investment, potentially great reward. The evidence doesn't need to be great for it, but I would also like to know, like, not to be surprised when it turns out I, you know, get sick at some point. Like, what? I drank the water. Like, that shouldn't be so surprised. You know, I'd be a lot more surprised if it was like fantastic evidence that this works, that this, you know, reduces cancer by 20% or something like that. Like fantastic evidence for it. And I'd be like, oh, well, I did that and it didn't work for me. Like, you know, I'd want to know.
So that was all the questions in the Q&A
and
chat.
Okay.
I just wanted to start by thanking the audience just for producing so many great questions. Just been very active and just really interesting questions. And of course, thank you, Mark, for your time and preparing.
Well, it's my pleasure. Thank you for indulging me. Thank you for indulging me. These are things that I've been thinking about for a while, and it's nice to have a great group to talk to about them. Thank you.